Greetings. Hello. Welcome. Let's talk about energy balance on a closed system. Right. So let's go ahead and define our system. We'll pick any region in space. It can be anywhere in the universe. As long as you're interested in studying that region, you can isolate it and then it becomes your system. In this case, we're down to Earth and we've picked a region of matter that we are interested in studying, and we have called that region our system. So inside the boundary that I've drawn is going to be our system. So this is my system. SYS short for system. Alright, and it's a closed system. CS meaning closed system. And let's just recap. What do we know about a closed system? A closed system is also known as a control mass. It's also known as a control mass. Alright. Meaning that the mass is fixed. The mass in a control system is fixed. Mass is fixed. It does not change. Alright, that's beautiful. So that's our system. And upon picking our system, there are a few things that we need to note about the system. The system consists of matter, and matter has energy. Any system at any point in time has energy. So we're going to indicate that, right? The system has energy, which is the total energy of the entire system. And outside of the boundary, this is the boundary. That whole yellow line here, that's our boundary. And outside the boundary, we have what we call surrounding. Alright. So, anything that is not inside our chosen boundary is what's regarded as the surrounding. Cool. And everything inside is our system. Okay, so that's our system. Very nice. System has energy at any point in time. That's cool. Cool. So our system is defined. It's a closed system. A closed system has no mass interaction with the surrounding. However, there is energy interaction. So energy can cross the interface and leave the interface in form of heat. Okay, so we can call that Q in and call that Q out. And at the same time, there is energy interaction for closed systems, to say, in the form of work. So work can be done to the system in order to achieve some objective that we are interested in. If we can, alright, so the objective would be work is done to the system so that the system can do some form of work. That is, work out. Nice. Okay. All these forms of system interaction, all these forms, energy in, heat in and work in, heat out and work out, all of these represent energy interaction of the system with its surrounding. And what we have here this would be what we call energy in, summation of all the total energy entering the system should be equal to the summation of all the energy leaving the system. That is, if the system was undergoing a cycle, right? In other words, so a cycle, that is to say cyclic process, that is to say the initial state conditions are the same as the final state conditions. In that case, energy in would be equals to energy out. However, that is not the situation we have in general. In our case here, when energy is supplied, either in the form of heat, or in the form of work, the system already has some form of energy. So what will happen is that there will be changes in the energy of the system. So energy supplied will cause changes in the energy of the system. And yeah, as that is happening, at the same time, simultaneously, there will be heat lost due to the processes the system is undergoing, maybe due to friction and other processes, other losses. And we'll also have our objective achieved, which is work being extracted from the system. So all of that can be represented as an energy balance, which is energy going into the system minus the energy leaving the system, will result in changes in the energy of the system. So this is what we call energy balance, the general energy balance equation. It's a very nice equation. So cool. So let's look at this some more. Let's expand on this a bit more, shall we? All right. Okay, cool. Here's our system. System we had before. The changes, it's undergoing a process because heat is being supplied, Q in, and there's some losses. There's heat being lost, Q out, and at the same time, work is being done to the system. So work in, and at the same time, work is being extracted from the system. Work out. Cool. So we defined previously that all of this is energy out. All of this was energy in. Energy in minus energy out results in changes of energy. The system, changes in the energy of the system. So energy in minus energy out is equals to changes in system energy. Okay, and we know that energy in is Q in and work in. So let's just write that down. So we have Q in to representing energy in, And we also have work in minus what we have as energy out. We have Q out plus work out, and all of that results in changes in system energy. Cool. Right, we can expand the bracket here, multiplying through, and that will give us, we'll have Q in plus work in minus, alright, just use the same color, Q out minus work out. That gives us changes in system energy. At this point, we can collect the like terms together. All the heat terms on one point and all the work terms on one side. Okay, so I'm gonna do that. Q in minus Q out plus work in minus work out equals to changes in the energy of the system. Alright, nice. So this is pretty cool. This term here, what you have here, is, we can define this as Q net. So Q net meaning the difference of heat that is going in and heat that is leaving the system. So Q net is Q in minus Q out. The difference of the heat is regarded as Q net. And in this case, Q in, heat being supplied, is greater than heat leaving. So this is actually Q net in. So it results in more heat being supplied in the system because heat being supplied is greater than heat leaving the system. So this is Q net in, which is equal to Q in minus Q out. Cool. So we are supplying heat to the system. And the other term we can also define it as work net, which is just the difference of work in and work out. So which is just work in minus work out. Alright, so if work in is greater than work out, this answer will be positive, and that means work is being done to the system. So we'll define this as work net in, work being done to the system equals to work in minus work out, which will give us a positive answer for this case. And this is not what we want. Okay, so let's write it down so we can simplify that equation to this equation here. Simplify it to Q net in other words, heat in overall, or the sum of the heat supplied, plus sum of difference of work being done to the system. So we can have changes in total energy of the system. Alright, and this is energy balance of a closed system. We could stop here. However, looking at this is telling us that, alright, let's reason. This is telling us that if heat is being added to the system and work is being done to the system, so that we could have changes in the overall energy of the system. But our point of interest here is we are not interested in the amount of work that is being done to the system. Rather, we are interested in the amount of work that we are extracting from the system, like the total work net out, right? And work net out, that should tell us that work net out would mean work out minus work in. So the work that should be extracted from the system should be greater than the work that being supplied to the system. And that is a type of system that we want in engineering, because would say it's an efficient system because we are supplying less work than we are getting out. Now, if you look at these terms here, look at this. If you look at work net out and work net in, you can already see the relationship that work net out, the relationship that work net out is actually equal to minus, if you multiply this, multiply that by -1, you'll end up having work net out. It actually equals to minus work net, work net in multiplied by a -1. Multiply that by negative, you'll get minus work net in. So vice versa is also true, meaning work net in is actually equal to minus work net out. With this term here, we can rewrite our work net in form of work net out, because we are interested in the work we are extracting from the system, right? Heat being supplied, we are supplying heat, that's okay. So heat being supplied, which is Q net in plus, okay, I'm not gonna change it here first, plus work net in is equal to changes in energy of the system. But then what we want is the work being extracted from the system, which is work net out. So we can rewrite this expression in terms of the work net out. So that becomes, now this becomes cool. Q net in, there we go, minus work net out is equal to changes in the energy of the system. And this equation here is an equation that you will see more often, that we are interested in using. So yeah, that's it for this video. Coming up will be a video to explain the terms found in energy of the system. What is this energy that is changing? We'll look at that in the next video. Thanks for watching. Cool.